My name is Aileen Drowan and my project is E-Textile Illuminations with Arduino LilyPad. My project includes two physical prototypes, one for the labyrinth and the second is for Lands of Light. There are similarities between both. They both use a master writer and slave reader configuration with communication over I2C protocol, utilising the Arduino wire library. The Labyrinth utilises a capacitive sensor library for capacitive touch sensing. Code-wise, both use the reset button. On the master device, the states are here, and on the slave, the child states are here. The enums here are messages that the master might send to the slave. The enums here are messages the slave might expect to receive. Play kicks off with button state changing to a value of 5 from the play button code here. So if a button press is registered, it causes a change state from idle into the countdown state. Countdown calls a countdown function which basically blinks an LED, and when the countdown is up, the state then transitions to the first of the fading states, fading up an LED, transitioning to the next state and so on, until the sequence on the master is finished. When the master reaches the end of its sequence, it signals the slave, so it sends a message to the slave. On the slave side, this message is picked up in a receive event handler. This then changes the state transition from idle to the first sequence state on the slave device. The master, after sending the play message to the slave, requests a response on the slave status. In the request event handler, we can see that only when the status state is idle will the slave write a value of 10, otherwise it will return a value of 8. The value of 10 is only returned when the slave finishes its sequence and the state is assigned to be idle again. There's a reset button also, so at any stage, if the reset button is pressed, a full reset happens. If we look at the reset all function, this calls a reset of the master, and it also signals the slave to reset as well. The reset of the master calls all LEDs off. It assigns the play and reset button states to be 0 again. It changes the master state to idle. It assigns the counter back to 10, and it assigns the counter over to be false. This is how the signal slave happens. So it takes there's two parameters, one for the address and one for the message. A transmission begins to this address with this message, and the message is sent on the end transmission. The master is monitoring the states of the play button, the reset button, and it's also getting the slave state, which is through another request. Every time a slave state updates, the master gets informed. In Lands of Light, the play button is not released until after the slave sequence has finished playing. I specifically wanted to make sure that play couldn't be activated on the master while the slave device was actually running its sequence. Otherwise, you could start play on the master and have the two things jarring against each other, excessively draining the battery as well. There is a slight change, but not reflected in the diagram. So when the master receives a read value in the code, a reset master function is called, which takes care of a lot of this. It sets the state back to idle. So this sequence over superfluous code, it's not needed. Previously what was happening is in case 5, if the sequence was over, The play button state changed, so this is now superfluous too. The play button state changed to 6, and sequence over was set back to 0 again, effectively resetting the play button back here. This is Lands of Light with a play button and a reset button, and battery is here. All the connections are buried behind the fabric. Master LilyPad, slave LilyPad, pull-up resistors in here, the conductive thread sewn in here to each of the petals. There are wires attached to more LEDs on the baseboard. These are soldered to snap connectors. So you have the front section and the back section. They all just get snapped into place. The capacitive touch sensors are made from conductive fabric. The first sensor you see here is the start sensor. You navigate the labyrinth in order to sensor 9 in the middle and back again. When the user passes the start sensor, the welcome LED turns off, and as sensor 1 is triggered, the first strip of LEDs turns on. When sensor 2 is triggered, the second strip of LEDs turns on and the first strip turns off. When sensor 3 is triggered, the third strip turns on for the user to follow, and as they pass then the fourth sensor, the fourth strip turns on and the third strip turns off. Sensor 5 is on the slave device, so a bit of communication is required to achieve the same effect we've seen with activating a sensor, turning on the next set of LEDs and turning off the previous set. The first thing that happens is the master writes a message to the slave, and the slave, on receiving this message, moves from an idle state into a standby state. In order for the slave to start reading sensor 5 values and activating the LEDs if the threshold on the sensor is breached. The second thing that happens is the master makes a request to the slave, and the slave responds to this request. The request that the master needs a response to is whether the sensor 5 has been triggered or not, in order to turn LED strip 4 off. So once then sensor 5 has been triggered, we have the LED strip 5 on the slave device has come on, and the LED strip 4 on the master device is turned off. And at this stage then the master sends another request. It needs to know when the user has finished navigating from sensor 5 into the center of the labyrinth and back to sensor 5 again, so the master can continue. Sensor 6 in all the way in here, sensor 7 is triggered, sensor 8 is triggered, and then as the user comes into the middle, we have a center one here as well. It's needed because if we don't have a center sensor and we're relying on sensor 8 as a trigger in and out, it just automatically happens. It's too fast. So we move back out to sensor 8. Sensor 8 turns on these LEDs. Sensor 7 turns on the next set. Sensor 6 back to here. Now we're at sensor 5 again. So at this stage now, when I actually trigger sensor 5, the LEDs on the slave turn off and the master's LEDs turn on. So I was saying before that the master is waiting for a reply, so it's now got the response it's looking for to turn on its LEDs. Once it gets that reply, it then also has to send a message back to the slave to tell the slave to turn its LEDs for this strip here off. After doing that, the slave kind of resets back to an idle mode, and the master then, the journey continues with the remaining sensors on the master to navigate the path out of the labyrinth. And when you get to the start position again, or to sensor 1, a little kind of reward plays. So you can see we're back here now again to the welcome LED blinking.